Hello, Cal2. We're here to do practice exam 3. Let's do it. We're going to use the disk washer method to find the volume resulting when the region bounded by y equals x squared and y equals 4x is revolved around the y-axis. What do these lines look like? X squared looks like this. Y equals 4x looks something like this. They cut the plane into 1, 2, 3, 4, 5 regions, and this is the only one that's bounded. So that is the region we're looking for. I see they intersect at 0, 0, but if I didn't see that, I'd still be setting x squared equals 4x to find where they intersect. X squared minus 4x equals 0, that's x minus 4 equals 0. Those intersect at x equals 0 and x equals 4. So these are the points that I care about. This one is 0, 0, 0. And this point is, what is that, 4, 16 is where 16 is 4 squared and is 4x. I try to organize everything in terms of either a horizontal line segment or a vertical line segment. We're revolving around the y-axis. If I want to end up with a disk or a washer, I need a horizontal line segment to reflect around, to rotate, to revolve around the y-axis is what will give me a disk or washer. So I need to do this for every y value, and I need to let my y's range from 0 to 16. I'm going to end up with an integral with respect to y from 0 to 16. This shape is a washer, not a disk, so my formula is going to be pi big radius squared minus little radius squared. How do I find those radii? They should be functions of y, because I'm expecting to end up with an integral with respect to y. What are these formulas? One of them is y equals x squared. That's x equals root y. So this x coordinate, given a y, is x equals root y. This x coordinate, I take y equals 4x and solve it for x. This x coordinate is x equals y over 4. So this inner radius is y over 4. And that outer radius is root y. Each of those is getting squared, so I'm integrating. This is pi integral 0 to 16 of y minus y squared over 16 with respect to y. It's not a hard integral. Half y squared minus 16 times 3 is 48 y cubed. Need to evaluate that from 0 to 16. Ooh, I got some big numbers. Pi 16 squared. Can I do that one? Yeah, I can. 16 squared is 256. Half of that is 128. Minus 16 cubed over 48. One of the 16s cancels. I'm left with 16 squared over 3. 16 squared is 256. So I need 128 minus 256 over 3. By the way, on the exam, it's totally reasonable to bail and just say, hey, it's whatever this is. I don't have time to add fractions. I'm in the middle of a big calculus test. Your calculus test doesn't care about your ability to add fractions. I'm going to go ahead and work it out so I can see if I get the same answer on the next problem. Here's what I like to do. 128 is half of 256. Now I can factor out the 256. What's a half minus a third? It's a sixth. I guess that reduces 128 pi over 3. That's what I'm getting here. I guess factoring out a 128 might have been simpler. Same region, this time using the shell method. Same points for the same reasons. This point is 416, this point is 0, 0. This time to end up with a shell-shaped region, I want to take a vertical line segment and revolve that around the y-axis. A vertical line, choosing a vertical line segment means choosing an x value. My x's are going to range from 0 to 4 to end up choosing all of them. I'm going to end up with an integral from 0 to 4 with respect to x. The shell method formula is the integral of 2 pi radius height. What's my radius? My radius is the distance from 0 out to x, is just x. I'll pull the 2 pi out. The height is the one that's tricky, is the distance from top to bottom, but these are already solved for us. The top is 4x, the bottom is x squared. I need 4x minus x squared to be the height of the shell. That's what we're integrating. 2 pi integral 0 to 4, 4x squared minus x cubed. It's pretty reasonable to just stop and put a box around this and say, hey, I'm a Cal 2 student. I know how to integrate this. I'm going to do it and see if we get the same thing. 4/3 x cubed minus 1/4 x to the 4th. I need to evaluate that from 0 to 4. I get 2 pi times 4 cubed times 4 makes 4 to the 4. I think that's that 256 again. 4 to the 4 over 4 minus 0. I get 2 pi times 4 to the 4 is 4 squared is 16 squared is 256 times 1/3 minus 1/4. 1/3 minus 1/4 is 1/12. Cancel that by 2. Cancel that by 2. I get 128 pi over 3. Same answer as the last page. Cool. If you don't get the same answer, don't spend forever trying to fix that. Move on. Don't stop taking the test. There's more problems. Seriously, adding the fractions is not a thing I care about. Like, what is this, a 14-point problem? Writing this down is probably 10 or 12 of the points, getting the correct formula written down. So, like, focus on that part. I want to use the midpoint rule, use Simpson's rule with the same delta x value. Okay, delta x is 0.5, so I'm cutting the interval 0 to 3 into subintervals of length 0.5. So this is 0 to 0.5, 0.5 to 1, 1 to 1.5, 1.5 to 2, 2.5 to 3. Oh, I missed 2 to 2.5. Midpoint rule's easy. The midpoint rule says the integral 0 to 3 cosine 2x is about, I need to take the midpoint of each of these 6 intervals. That one should be in between those two. And plug them all into this function. So cosine of 2 times the midpoint of this is 1/4. Should I do that? I guess it'll be less writing if I do the doubling. Double a fourth is a half. Cosine of double 3/4 is 3/2. Cosine of double 1.25 is 2.5. Cosine of double 1 3/4, what is that, 7/4? That's 7/2. Cosine of, I'm starting to lose track of the doubling, so I'm just going to write out doubling 2.25. Cosine of doubling 2.75. What's the number that goes out front? You're multiplying by delta x. If you can remember that, that's great. I like remembering that it's the length of the interval is 3 minus 0. Needs to get multiplied by an average of these values. We've added up 6 values. To average them means dividing by 6. This is 3 over 6 is 1/2 is delta x, so we're doing the correct thing. Either way, this is the way I like to remember it. This is the midpoint rule. Riemann sum. What's the Simpson's rule one? This is the deal where I need to take it's the 1424241. And I'm going to use these points. 1, 4, 2, yeah. Cosine of the first point is 2 times 0. Second point is cosine of 2 times 0.5. Cosine of 2 times 1. Cosine of 2 times 1.5. Cosine of 2 times 2. Cosine of 2 times 2.5. Cosine of 3. And my coefficients should be 1, 4, 2, 4, 2, 4, 1. And the number out front should be the length of the interval times an average of values. The averages of these values would be adding them up and dividing by how many points did we add up. We added 1, 4, 2, 4, 2, 4, 1 points. That's 12, 13, 14, 15, 16, 17. I'm getting 18 points total. Cool. There's a little bit of ambiguity here. You might look at this and read if delta x is 0.5, then I should be using the values 0.25. So maybe you think it should be 1 cosine 0 plus 4 cosine of... Use the midpoint of this interval, because that's what I did on the midpoint rule just a second ago. 2 times 0.25, 2 times cosine double 0.5, and so on like that. And I wouldn't take any points off if you did that, but that was not the intent of delta x being 0.5. But that will give you a different error estimate. And I would probably just give you the n instead of the delta x thing, because we didn't talk about the delta x that much in these lectures. Those are our estimates. We don't care about these values. We don't have a calculator. I also need to find an error on the bound of my approximation. The hard part of the error bounding thing is finding this k2 is how big does the second derivative get. This is a cosine. Cosine and sine are nice because they have easy... their derivatives are sines and cosines, which are easy to bound. F is cosine 2x. F prime is 2 cosine... no, negative 2 sine 2x. F double prime is negative 4 cosine 2x. F triple prime is 8 sine 2x. Triple prime... yeah, that's triple prime. This is quadruple prime is 16 cosine 2x. How big does the second derivative get? Never bigger than 4. Because cosine never gets bigger than 1. And the absolute value of negative 4 is 4. How big does the fourth derivative get? Never bigger than 16. Because cosine stays smaller than 1. Cool. So the midpoint rule error is at most b minus a was 3, so 3 cubed times how big is the second derivative? It's as big as 4, divided by 24 times n squared. What's n? It's the number of subintervals we broke this into. Was 1, 2, 3, 4, 5, 6. So this is 3 cubed times 4 over 24 times 36. Is this worth reducing? I guess this is worth reducing. This is a 9 on bottom. That cancels with that. I'm getting 1 over 24. What's the Simpsons rule error? It's at most, length of the interval is 3 to the 5th. K4 is at most 16 over 180 times 2n to the 4th. 2n is how many intervals. If I'm using this cut in half version, the number of intervals is 6. We had 3 pairs of intervals, so my 2n is now 6. How is this going to reduce? 6 to the 4 is 2 to the 4 times 3 to the 4 is 16 times 81. Don't worry about reducing these. I'm doing it because I'm being a butt. 3 to the 5th. 81 is 3 to the 4th, so that'll cancel and leave a 3. I'm left with 3 over 180, that's 1 over 60. These are the bounds I'm getting. I don't think you can get better bounds because I think you have to use 16 as your 4th. Like sometimes there's some ambiguity of if you think really hard you can come up with a better error estimate on this. Like cosine actually does get as big as 1, and I think it does it on this interval, so I don't think there's any. I think this is the best the error can get. Here's a parametric curve. Let's find an equation of the tangent line at t equals 1. I'm going to want x of 1 is 1 squared plus 3 is 4. I'm going to want y of 1 is 1 minus 1 plus 4 is also 4. That's bad. Don't write exams where you get the same number twice. And to find the slope of the tangent line, it's dy dt over dx dt. What's the derivative of y with respect to t? It's 3 times t squared minus 1. What's the derivative of x with respect to t? It's 2t. So dy dx at t equals 1 is 3 minus 1 is 2 over 2 is 1. So I'm getting the slope is 1. So I can write a tangent line as y equals the y value plus the slope, x minus the x value, and I have all those things. It's going to be y equals 4 plus 1, x minus 4. If you are crazy about slope-intercept form, you can do that, but I don't care. Also find the second derivative at t equals 1. To find the second derivative, I need to think of this as being the derivative with respect to x of dy dx is the derivative with respect to t of dy dx divided by dx dt. My dy dx formula is this. Make sure when you're doing this, don't take a derivative of something after you've plugged it in. If I tried to take dy dt and look at this and say the derivative of y with respect to t is 0 and the derivative of x with respect to t is 0, then I'd be getting 0 over 0 as undefined. You can't plug numbers in before you take derivatives. If you're going to take a derivative of an equation, it needs to be an equation that is always true. Dy dx is always this, so the derivative of that with respect to t is the quotient rule. Derivative of the top is 6t. Leave the bottom alone is 2t. Minus leave the top alone is 3t squared minus 1. Derivative of the bottom is 2. All over the bottom squared. So that's the derivative of dy dx. This needs to get divided by dx dt, which was 2t. This simplifies some. We don't need to simplify this at all. It's reasonable to just stop and plug in 1 here, but I think it'll be easier to plug in 1 if I clean this up a little bit. I get 12t squared minus 6t squared plus 2. I'm getting 6t squared plus 2 over 2t cubed. So the second derivative at t equals 1 is going to be 8 over 2 cubed is 8, is also 1? Crud. Dang. What do I get if I plug 1 in here? I get 2 on the bottom of this, and on top of the big fraction I get 12 minus 2 times 2 is 4 over 2 squared is 4. Yeah, I'm still getting 1. I didn't make a mistake simplifying. It sucks when all the answers are the same, because it's, harder to grade. I guess it's easier to grade, but harder to verify you're using the right numbers at the right points. State 3 terms of the Taylor series of the curve at this point. This is take the tangent line and add one more term. It's y equals y value plus the slope, x minus the x value, plus the second derivative over 2 factorial x minus the x value squared. There's the 3-term Taylor series. Cool. 5. Write an interval that gives the arc length of the curve from t equals 1 to t equals 5. Arc length is the integral of the square root of dy dt squared plus dx dt squared. This will be the integral from 1 to 5 of the square root of derivative of x with respect to t squared. Derivative of that is 2t squared plus derivative of y with respect to t is 3t squared minus 1 squared dt. Done. You do not need to evaluate the integral. Look how I made that in bold. Don't waste an hour trying to evaluate an integral. I told you don't have to. Let's make a sketch of this parametric curve. What does my x-coordinate look like? My x-coordinate looks like t squared minus 4. I know that intersects the y-axis at -4. It intersects the x-axis at plus or minus 2. This is my x-coordinate. What does my y-coordinate look like? My y-coordinate is just increasing through 0. It's t cubed plus 2. So something like that. Oh, I don't think they intersect at the same point here. What do I get if I plug in -2 to that? I get -6. So yeah, I don't want to make it look like this thing crosses 0 at the same place as this. It doesn't. It crosses 0 like somewhere to the right of there. I don't know where these intersect. I don't think that matters. So I want to come up with a sketch of that. I care about places where these things turn around. I care about places where these things cross the x-axis. I guess I should solve this. When does t cubed plus 2 equal 0? That's at t equals negative cube root of 2 is negative 1 point something. I don't know when that is. I got a purple point here. I'm coloring these points just so you can see which point I'm thinking about when I do it. Color is not necessary to do the problem. This is just me trying to make sure you can understand where these points are coming from. What do I have? Out on the left, my x values are positive. My y values are negative. So I'm coming in from quadrant 3. My first point of interest is the red point where x equals 0. What does y equal there? We're at t equals -2 is where I get x equals 0 and y equals -2 cubed plus 2 is -6. So 1, 2, 3, 4, 5, 6. Here is a point of interest. And I'm going to label this as the red point. Prior to that point, I was out here somewhere. I don't know if I was concave up or concave down. That would probably be some work to work out. But something like this. Next point of interest is the place where the y hits 0. That is at t equals negative cube root 2. I get a y value of 0 and an x value of, square that and subtract 4. Squaring it'll give me a positive 2 to the 2/3 minus 4. That's the cube root of 4 minus 4. I don't want to try and get digits on that, but it's negative. Yeah, so some negative value will be the green point. What happens next? Our next point of interest is this purple point. At t equals 0 is where I get a y value of, I get an x value of -4, I get a y value of +2. And the significance of this point is this is where my x's stop decreasing. So this is the purple point. My y's are still increasing. My x's switch to decreasing, something like that. What's my last point of interest is this blue point, which is at t equals 2. I get an x value of 0. I get a y value of 2 cubed plus 2 is 10. So if this is 1, 2, this is real ugly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's our point. So something like that. And after that, x's and y's are staying positive and they're staying increasing. I get something like this. The points I really care about are that this is t equals negative 2. This is t equals positive 2. These points over here exist, but I don't particularly care about them. I want the total area bounded by this curve and the y-axis, so that's this region. How do I find this area? Two ways to think about area are integral of y dx, integral of x dy. This would look like a totally standard calculus integral if I turned the paper sideways. So that is the simpler way of thinking about the thing, at least to me. I'm going to think of this as the integral of y dx. I bet you get the exact same thing if you do it as the integral of x dy. But you have to like draw a picture and figure out what's going on, and some of this stuff is positive and some of this stuff is negative. What am I going to get if I think about the integral of y dx? It's going to be from negative 2 to 2 of y of t dx dt. No, wait, why did I... Integral of y dx is what I would do is if I had the area between this and the x-axis. That's the regular calculus integral, is integral y dx. This one is the sideways version. It looks more simple to do this as x dy. I was saying the right stuff, but backwards. Integrating x dy looks like the straightforward thing to do. Throughout the entire time, dy dt is always going to be positive. Throughout the entire region, these x coordinates are always going to be negative. So I'm integrating negative values times positive values. I'm going to end up with negative area the whole way through, so I'm going to stick a minus sign to fix it. The integral is going to be... Here's a heads up. Don't be one of these people who starts setting up the problem and at the end says, oh, I got a negative, I better make it positive, that's the answer. You want to walk into this knowing if your answer is going to be negative and then confirming your hypothesis. This is just like the smart way of doing things. Okay, I want to integrate negative 2 to 2. What's my x function? It's t squared minus 4. What's my dy dt? It is 3t squared dt. So this is negative integral, negative 2 to 2 of 3t squared times t squared minus 4 will be 3t to the 4th minus 12t squared. Integral of that is 3/5 t to the 5th minus 4t cubed. I need to evaluate that from negative 2 to 2. I'll plug in negative 2 first to deal with the minus sign. Negative 2 to the 5th is negative 32 times 3 is negative 96 over 5. Plug in negative 2, I get negative 2 cubed is negative 8 times 4 is negative 32. I'm subtracting a negative 32. Minus, now I'm going to plug in the positive 2, and I get the same numbers but opposited. I get positive 96 over 5. I get negative 32. So I get 64 minus double 96 over 5. Double 96 is 192. It's totally reasonable to stop and put a box around this. I guess I will just stop and put a box around this. You don't need to show me, you can add the fractions. Eliminate the parameter to write y as a function of x or x as a function of y. Let's do it both ways. Solving y, I need to solve one of these equations for t. Solving the bottom one for t looks easier. Y minus 4 equals t cubed. T is y minus 4 to the 1/3. So x is going to be, plug that into there. Y minus 4 to the 1/3 squared is 2/3 minus 9 y minus 4 to the 1/3. Here's x as a function of y. To do it the other way around, I need to take this and solve it for t, which is doable but more of a pain. I get everything to one side because it's a quadratic, t squared minus 9t minus x equals 0. When I'm trying to solve for t, I'm pretending that x is a constant, so I can use the quadratic formula here. T is going to be the opposite of b, plus or minus the square root of b squared is 81, minus 4 times a is 1 times c is negative x, all over 2a is 2. So this is 9 plus or minus root 81 plus 4x, all over 2. To get y as a function of x, I need to take my formula for t in terms of x and plug it into y. So y equals that thing cubed plus 4. 9 plus or minus the square root 81 plus 4x over 2. These are allegedly the same. Write this curve in polar coordinates. X becomes r cosine theta. So I get r cosine theta equals 2. I can put a box around that. The normal thing to do is solve for r, so I get r equals 2 secant theta. Whichever one. These are both in polar coordinates. Check. Using polar coordinates, find the arc length of the curve from 0 to pi over 3. Well, x equals 2 is a vertical line. I know how to find the length of a line. That's the one I can do. If you have a straight line and you want to go from theta equals 0 to theta equals pi over 3, what is my y-coordinate there? Because this is going to be root 3 over 2, but it's doubled because, so this is going to be x equals 0 to x equals root 3. I think this is 2 comma root 3. This arc length is going to be root 3. It's very easy to just look at the graph of the vertical line and say the arc length is going to be root 3. That's not what the problem's asking for, though. It says using polar coordinates, find the arc length of the curve. This is generally the case that the versions of the integral that come out doable are doable because there's an easy way to do the problem another way. This problem's leaning into that, saying, hey, it's easy to do this another way. Do it using the polar coordinate arc length formula. The polar coordinate arc length formula is it's the integral of r squared plus dr d theta squared square root. So our arc length is going to be the integral from 0 to pi over 3, that part was given straightforward, of the square root of r squared. R squared is 2 secant theta squared plus dr d theta. What's the derivative of r? Derivative of secant is secant tangent, so 2 secant theta tangents theta squared. What's this integral turn into? Oh, d theta. There's a 4, square root of 4 is 2, I can pull that all the way out of the integral. If both of these have a 2, we can factor that out. I get square root of secant squared plus secant squared tangent squared. There's a factor of secant squared I can pull out. That leaves in 1 plus tangent squared, which is another secant squared. On this interval from 0 to pi over 3, cosine is positive, so secant is positive, so the square root of secant squared is just secant. This is secant. This is square root secant squared is also secant, so I get secant squared. The integral of secant squared theta is tangent theta. I'm doing the integral now, so the integral goes away. I need tangent theta evaluated from 0 to pi over 3. What's tangent pi over 3? Cosine is root 3 over... Well, wait, no. Cosine's a half. Sine is root 3 over 2. Sine over cosine is root 3. Minus, plug in 0, you get 0. I'm getting 2 root 3. Should I have gotten 2 root 3 there? Root 3 over 2. I think it should have been just root 3. What am I doing wrong here? Did I pull out the 2 wrong? The 2 gets squared, it's 4. Factor it out, pull it out of the square root, it's 2 again. The integral looks solid. Did I draw the triangle wrong? Okay, the standard triangle would be 1. Oh yeah, I did draw the triangle wrong. Okay. The triangle went wrong. It's this triangle. I need to scale it by a factor of 4 to end up with 2 and 2 root 3. Yeah. Okay. Cool. The length should have been 2 root 3, not root 3. So this is correct. The other one was wrong. Neat. Let's keep going. Sketch the graph of r equals cosine 3 theta. These are tough. What does cosine 3 theta look like if I just draw it as a function of y as a function of x? Cosine starts at 1, goes down up. If we're doing triple, then over the regular 0 to 2 pi, it's going to do that 3 times. Normally, it would go down once, up once. We're tripling that, so it needs to do that at 2 pi over 3. So between here and here, it's going to go down and up. And it's going to cross 0 at pi over 6. 2 pi over 6, 3 pi over... yeah, wait. So something like that. So when I try and sketch this in polar, we're going to start out at 1. It's going to cross 0 at pi over 6. Let me make some sketches of this. Here's pi over 3, pi over 6, 2 pi over 3, 5 pi over 6. So between here and 2 pi over 3, we're going to go r equals 1, r equals 0, r equals negative 1, r equals 0 again, r equals 1 again out here. Have I done this right? Yeah, 2 pi over 3 is the place where it equals 1 again. So, okay, yeah, this is pi over 2. This is the fraction I was getting confused reducing in my head. So, we need to start at 1, decrease down to 0, keep decreasing to a negative 1 here, So at pi over 2 is where we're going to reach our -1. Then equal 0 again when I reach 90 degrees, and then hit 1 again. Wait, no, something's gone wrong here. Oh, yeah, I came through at the wrong spot. This is the angle where I'm passing through 0. Here's where I hit -1. I lost my vertical axis. Here is where I get r equals 0. Here's where I get r equals 1 again. Okay, here's one curve, and then do that again. 0. 1, 0, -1. Okay, we've looped back on ourselves. 0, -1, 0, 1, 0, -1, 0, 1 again. Yeah, so going 0 to 2 pi will include this whole loop twice. This is one of these where it's passing through the entire curve twice. So when I find the total area bounded by the curve, I should go from 0 to pi, not 0 to 2 pi. Going 0 to 2 pi will catch the whole thing twice. How do I find the formula for area? Area is the integral of half r squared. Crashing. Yes. Yes. Yo, I'm back. I went on mute to enjoy a tasty beverage. And the key thing is don't integrate 0 to 2 pi, integrate from 0 to pi. Doing the sketch showed us the curve gets hit twice, is where we learned don't go all the way out to 2 pi, like you normally would for a trig function. 1/2 of my r thing is cosine, so I need cosine squared 3 theta. How do you integrate cosine squared? You need to use a trig identity. I'll pull out the 1/2. Cosine squared is 1 plus cosine 2 theta. Doubling 3 theta gives 6 theta over 2. Let's pull out another half. I get 1/4. I guess I can do the integral. The integral of 1 is theta. The integral of cosine 6 theta is sine 6 theta divided by 6. Need to evaluate this from 0 to pi. I get 1/4 of pi plus 0 minus 0 plus 0. I get pi over 4. Cool. Does that make sense? The area of a circle of radius 1 would be pi. Does it make sense for this to be a quarter of the circle? Yeah, I can buy that. Yeah, it seems reasonable. Convert these things from polar to rectangular or vice versa. R equals sine theta. Easy thing to do is multiply both sides by r. I get x squared plus y squared equals r sine theta is y. Y equals x squared. This says r sine theta equals r squared cosine squared theta. If I want to solve for r, I guess I divide both sides by r. Divide both sides by cosine squared theta. We don't have to solve for r, by the way, but if we can, it's not too hard. I get r equals sine theta over cosine squared theta. What is that? Secant theta, tangent theta? R equals tangent theta. Tangent theta is y over x. Do I want to multiply both sides by r? This gives me x squared plus y squared. But there's nothing to do with this extra r. The extra r can't get soaked up into anything, so that's not helpful in this case the way it was over there. Tangent theta is y over x equals the square root of x squared plus y squared. Let's not try and solve for y. Y equals 2x, that says y over x equals 2. That says tangent theta equals 2. I might go so far as to say theta is tangent inverse 2. That does give me all the values, but tangent theta equals 2 is likely easier to use. And that's the end. I got a text asking me to do number 140 from the homework, so I'll do that. Do I still have the homework open? Here it is, 140 from the homework. I guess I should zoom in before I copy it. Zoom, zoom, zoom. Zoom. To find the area enclosed by this curve and the x-axis, I probably want a decent estimate of what does this graph look like. T squared minus 2t intersects 0 at 0 and 2. It's got its vertex at 1. 1 squared minus, that'll be negative 1 here. But this part of the graph doesn't matter. So this is x of t. Y of t is square root t only exists on t positive. So the fact that x exists to the left doesn't matter. I can't plot those points either way. This graph starts at 0, 0. X is increasing and y is decreasing, so that puts us going this direction until t equals 2 is when our x coordinate. Okay, so y is increasing, t is decreasing. At some point, our x-coordinate equals 0 again. I guess I should get some points plotted out. T equals 0, t equals 1, t equals 2 are my points of interest. I'd like to get these points correct on my graph. I get 0, 0 at t equals 0. At 1, x of 1 is negative 1, y of 1 is square root 1 is 1. So here's the point, 1, negative 1. At 2, I have x is 0, y is root 2. So this should not be at. So I could do something like that. And then after that, x is always positive, y is always positive. So something like that. So that's the time t equals 2. The area enclosed by the curve and the y-axis. That nothing is enclosed by the curve and the y-axis. So this doesn't work. This should have been and the x-axis. Can I fix that real quick before I forget to? Not exam 3. That's this one. So that should have been enclosed by the curve and the x-axis is the one that makes sense. Nope, that didn't fix anything. X. Cool. That area will be the integral from t equals 0 to 2. of y dx. Will it come out positive or negative? My y values are negative. My dx values are positive. Wait, y values are... I've done this picture wrong. Something is wrong here. My y values are supposed to be positive. I did the picture wrong and the problem was right. Change that back to a y. Save that. Let's check this picture out again. Okay, I can't... None of these points are at the places I drew. Let's fix this. I wrote the points down correctly, and then I drew them incorrectly. 0, 0. Negative 1, comma 1 is over here. 0, comma root 2 is up here. Okay, so something like that. X is negative, Y is positive. Okay, I have my X's and Y's switched the first time I drew this. Okay, so between the curve and the y-axis does make sense. It makes the most sense to think of it as the integral of x dy. My x values are negative, my dy values are positive because y is increasing, but x is always negative on this region. So I'm going to want negative integral from t equals 0 to 2, t squared minus 2t. Derivative of y is 1/2 t to the negative 1/2 dt. This is an improper integral. The function goes, well, no, after you multiply that into the other thing, it stops being improper though, but that's a thing to look out for. The t to the negative 1/2 goes to infinity at 0, so there's something hinky going on there. Okay, that's the area, but the question was actually about the Taylor polynomial part. So, you know, do the integral to get the area. It's not an interesting integral. Let's find the first three terms of the Taylor series at t equals 0. I think this one, the thing doesn't make sense because the derivative of y doesn't make sense at this point. To try to find dy dx, it'll be dy dt over dx dt. But the derivative of y is 1/2 t to the negative 1/2 is undefined at 0. dx dt is fine, it's 2t minus 2. So I'm getting 1 over 2 root t times 2t minus 2. Can I plug 0 into this? Can I take a limit at 0? No, I have no chance at all, right? Crud. Yeah, so sometimes these things do have a limit as you approach a point. You get a 0 over 0 thing or an infinity over infinity thing. I'm getting infinity over negative 2 is like, there's no chance that the limit exists at all. So, find the first three terms of the Taylor series, you can't do it. It looks like at this point we have a vertical tangent. Like this thing looks like this or something. Should I grab a different point to do? Huh. Is this saying to do it at t equals 0? I meant to put 1. What's a good way of phrasing this question? Like, I meant to have a problem where you can't do it and observe this fact. But the phrasing of this question is not so great. Oh, did I already change the problem? Is this... version looks different than that. When did I change this? What does it look like on Blackboard? No, that's the practice exam. Oh, okay, I've already tried to change the problem to not be at t equals 0. So, okay, you can't do it at t equals 0. The version I posted on Blackboard is messed up. It looks like I noticed that and fixed it, but didn't post it on Blackboard, and I don't remember when that would have happened, because I just started talking about this material this week, so... Okay, instead of... I guess pause this video and try doing it at t equals 1 and t equals 1/4. Instead. That is the version of the problem I just rewrote. Let's try that. Sorry about that. We need dy dx, we need d squared y dx squared. Dy dx is the derivative with respect to t over the derivative of x with respect to t. Dy dt is 1/2 t to the negative 1/2. Dx dt is 2t minus 2. So I get 1 over 2, I guess 4 if I factor out that other 2, root t, t minus 1. This might be cleaner to rewrite as 1 over 4 t to the 3/2 minus t to the 1/2. I don't know what's the better to take the derivative of. I guess they all suck. Oh, I can rewrite this as 1/4 t to the 3/2 minus t to the 1/2 all to the negative 1 will be easier to take the derivative of, I guess. It would be if I could read it. This is 1/4 of t to the 3/2 minus t to the 1/2. The thing I'm fussing over is I'm about to need to take the derivative of this with respect to t for d squared y over dx squared. So I'm trying to rewrite this in whatever way makes it easiest to take the derivative of. So I need derivative with respect to t of dy dx divided by dx dt for the second derivative one. So what's the derivative of the top with respect to t? It's the derivative of this with respect to t is 1/4 of negative 1 stuffed to the negative 2 times the derivative of the inside is 3/2 t to the 1/2 minus 1/2 t to the negative 1/2. Gross. Over derivative of x with respect to t is still 2t minus t. 2. Part of the good news is we don't really... We're just going to plug numbers into this. So maybe we don't need to simplify this at all. But on the other hand, we do need to plug 2 different numbers into this. So like any simplifying we do will give us like double value. Let's try this. Negative 1. The 1/4 I'm going to put on bottom. That'll be a 4 on bottom. This is stuffed to the negative 2. It's going to be that thing squared. That thing before I FOILed it out was root t, t minus 1. When I square that, I get t, t minus 1 squared. So that goes on bottom. On top, I have 3/2 root t minus 1/2 1 over root t. I can factor a 1 over root t out of this or something, and that'll clean it up a little bit. That feels like too much work, though. I'm going to leave that alone. On bottom, I have another 2 t minus 1. Yeah, I guess I'm just going to leave it like this. So there's d squared y over dx squared. So, to do one of these Taylor series things, I'm going to need what is the x value, I'm going to need what is the y value, I need what is dy dx, I need what is d squared y dx squared. Let's do all these things. At t equals 1, I have x equals 1 squared minus 2 times 1 is negative 1. I have y as the square root of 1 is 1. I have dy dx is plug 1 into this. What's the best place to plug 1 in? Probably here. What? I get another undefined? Ah, it's undefined. Oh, okay. That's how I fixed it. It's a place where the thing is undefined, can't do it. Okay, but now at t equals 1/4, we probably can do it. Boy, I sure hope so. At t equals 1/4, we get x equals a 4th squared is a 16th minus a half. A half is 8/16, so I'm getting negative 7 over 16. I get y is the square root of a 4th is a half. I get dy dx is, I'm going to plug it into this version, 1 over 4 times the square root of a 4th is a half, times a 4th minus 1 is negative 3/4. That's 1 over negative 3/2. I think this is negative 2/3. And what is d squared y over dx squared? That is negative 1. 3/2 of 1/4, or square root of a 4th is a half, minus half of 1 over square root of a 4th. Square root of a 4th is a half, 1 over that is 2. On bottom I get 8 times a 4th times negative 3/4 squared is 9 over 16 times a 4th minus 1 is negative 3/4. Okay, how bad is this? Negative 1. 3/2 of a half is 3/4 minus half of 2 is 1. This is all negative 1/4. This is all, the top of the fraction is all 1/4. What do I have on bottom? 8 times a 4th is 2, times 9/16 makes 9/8 times negative 3/4. These are both on bottom of the fraction. If I flip those on top, I get 1/4 times 8/9 times 4/3 negative. I'm getting negative 8 over 27 is d squared y over dx squared. I got this, I got this, I got this, I got this. This is the one we can actually do. So our Taylor polynomial at this point is y value plus dy dx, x minus the x value, plus d squared y over dx squared, divided by 2 factorial, x minus the x value squared. Cool. If I'd known I couldn't plug t equals 1 into the derivative, I wouldn't have bothered simplifying the second derivative. I would just be plugging 1/4 into here, hopefully getting the same answer. There's what that homework problem's supposed to look like. The version that I posted was not doable. Sorry about that. And I think that's it. If you have any more homework questions, let me know. I can come back and make more videos. See you around.